All right, how's everybody today? Doing good. Good, good, good. Good to hear. We are going to continue moving on with our reviews. We should actually be able to get through review 4 today. We'll go ahead and most likely, I'm hoping, start review 5, and we'll just continue to do so. I'll go ahead and let you know when your next exam is going to be. I'm actually kind of messing with the idea of doing this on Monday, just getting the test out of the way, making sure we have all of our grades, and then focusing again on, just the review. Okay, let's look at the door. Hello. Is everybody continuing to look at the reviews? Has anybody taken advantage of the link I provided for OSC, for the online problems that have the video tutorials with them? They label it as easy, medium, and hard levels? Not yet? Okay. Does anybody remember that? Do I need to show you? No? Okay. That is available. Remember, if there's any particular topic you're wanting some extra problems or practice on, that is available. I want to say I posted it like a week or two ago, okay, to the website. If you have any trouble locating that, just let me know. Okay. Well, let's see what we got here. We're on review 4, and it looks like we have normal distribution problems. Okay, so it's been a while since we've brought up that topic. It says speed checks on a very large number of cars at a certain point on a motorway show that the speeds are normally distributed. 10% of cars have speeds more than 132.8 kilometers per hour, and only 7% of cars have speeds less than 103.2 kilometers per hour. So A, draw a normal distribution diagram to illustrate the information, indicating clearly both the percentages and the speeds. All right. So let's see if I can do this real quick. Nice straight line here. Okay. There we go. Okay, so there's my normal distribution curve. Now remember, a lot of information we're going to be bringing up with this topic as we move forward, but does anybody remember what percent is contained below this curve? It was 99.7, yes. And the way we were looking at standard deviation was that we went 3 above and 3 below. Okay, we added it above, we subtracted it below. And I'll remind you about all those different percents in just a moment. But here, we're talking about speeds. Okay, so we have a 132.8, okay, that represents 10%. So maybe I'd go ahead and put it right here, 132.8 kilometers per hour. And then we've got 7% of cars have speeds less than 103. So I'm just going to go ahead and kind of guess 103.2. So I would go ahead and say that this represents the 10%, and this right here would represent the speed of the vehicles. Okay, 7% of which are at 130.2 kilometers per hour or less. Okay. All right, questions. That one's pretty easy and straightforward. I did want to go ahead and work this problem, even though B was here. It says, given that the standard deviation of the speeds is 10.7. Okay, remember that's the standard deviation, so we use that symbol. Calculate the mean speed of the cars, so there's mu, that little symbol we've been using for that. In order to do this, you would have to use what's called z-values and use a table. That's not currently part of IB, so don't worry about that. You will not be asked to find z-values. That's why I went ahead and worked the problem for you. We know that the mean is going to be 119.104. So if I were to go back over here, remember, dead center is always where you put the mean. So this would be 119.04 kilometers per hour. Okay. And then you have the standard deviation going up and above. Okay. So it says, calculate the percentage of cars traveling at more than 130 kilometers per hour. Okay, so I'll go ahead and show you that in just a second, but if I'm looking at the graph, actually I'll go back up to this one since I've already got it drawn. It says 130 kilometers per hour, so let's say that might be right about here. Okay, so I'm looking for the percent of cars that are going to be traveling faster than 130 kilometers per hour. Yes? I already calculated that for you. You have to use what's called z-values, and we don't know about that, so just trust me that the mean is 119.104. No. You will not be dealing with z-values on the test. Okay. So they will not even bring up z-values on the test. This problem just had it involved in it, so I just went ahead and solved it for you. Okay. Yes? Oh, yeah, more than likely, like the next problem, number 2, they'll go ahead and just say, here's the mean, here's the standard deviation, go ahead and calculate this probability. Okay, so that's more in tune with what you're going to be expecting to see. So if I were to go ahead and write this out in the notation that we saw, I'm looking for the probability of my value being greater than 130. You guys remember when we did problems like that? Okay. Do you remember where we solved those? The nice thing was all of these problems were done on the calculator. Do we remember the keystrokes? Okay, so I'm going to go over here to the calculator. All right, let me go here. I'm going to go to calculate, if it will let me. There we go. So we definitely want to go to menu. Okay, not probability. We do want statistics, but this is one we haven't chosen in a while. Distributions, because remember, this is a normal distribution problem. So I'm going to choose distributions. Normal CDF is what we want. We want CDF. Are you okay? Okay. We want normal CDF. And remember, you had a lower boundary and upper boundary, and then you were going to go ahead and plug in the values for both the mean and the standard deviation. So the problem here was specifically stating, I want the percentage of all the cars traveling more than 130. So that's why I went ahead and wrote it as x greater than 130. So that means that 130 is my upper or lower. That's the lower. So what I'm going to go ahead and do here is I'm going to come back over here. Now, if it's less than, that would make it the upper bound. I would type that in. You would want to leave the negative 9e to the 999 by itself. That's scientific notation. That's an extremely small number. But I'm going to go ahead and type in my 130. Okay. But now I do need an upper bound. You guys remember what we did? Just fill it with 9s. Just 9. That should be enough 9s. Okay. And then I'm going to go ahead and put in the mean that I got. What was it? 119.104? 119.104. 104. And then the standard deviation, what, 10.7? Yes. Okay. 10.7. Okay. So according to this information, what's the percentage of cars that are traveling higher than 130 kilometers per hour? I click OK. OK. So I'd say about 15.4%. Okay, remember, you got to move that decimal over twice, multiply by 100. Okay, 3 sig figs. So about 15.4%. And I remember, Eli, you were asking about this problem specifically. Is it starting to come back to you?
Yes, I forgot that we could do this later, so I was like,
okay. Now, there were some problems that we didn't work on the calculator, but the questions have to revolve around specific intervals of the standard deviation. Okay, so let's go over to this right here. Now, I didn't go ahead and worry about finding the values. See, I went ahead and put the mean here, and we can still work with this problem if you want, the 119.104. But remember, typically we go 3 standard deviations above. So I add 10.7 plus 21.4. So where'd that 21.4 come from? There you go. So 10.7 plus 10.7 plus 10.7. And see, the third time, there's 32.1. So remember, the standard deviations above, you just add that 3 times. For the standard deviations below, so I subtract 10.7. I subtract 2 times 10.7. I subtract 3 times 10.7. Okay. You guys remember that? It's been a while since we talked about one of these. Now, let's talk about those percents. Okay. Now, Eli is absolutely correct. We're looking for 99.7% of our information to be below this curve, within the 3 standard deviations, right? Okay. So we had that broken up into 3 different quantities. Does anybody remember, within 1 standard deviation, what's your percentage? Between these 2 right here. 60, oh, a little higher. 68. All right, so from here, remember this was 68%. And then we'll go back and fill in the individual columns in just a moment. What about within 2 standard deviations?
Like 83.
Ooh, a little higher. A little higher. We're in the 90s.
95.
Okay. Wow. Okay. So I'll tell you what. Look back in your notes real fast. Because this one I want you to remember. Okay. I'll even go ahead and do this, and maybe you could just add it up real fast. If this is 68%, remember this graph's got to be symmetrical, right? So that...
Teachers and students, pardon this interruption. Teachers, Mr. Anderson sent out a list of students that are needed in the old cafeteria. I believe he sent that email out yesterday or the day before. Please check that email and send those students that are on that list to the old cafeteria. Again, please check your list and send those students down to the old cafeteria. Thank you.
95.
Boom. There you go. 95%. Okay. And remember, it's symmetrical, so is everybody okay where I came up with the 13.5? Okay. Because if we realize within 2 standard deviations, if this is supposed to be 95%, so we've already got 68%, but these 2 sections are going to be identical to each other. So I just took the remainder, divided that by 2. Okay, the 27. All right. And then now we know within 3 standard deviations, okay, that's going to be the 99.7%. So what are these remaining areas, their percent's going to be? These were the smallest. 2 point what? I heard 2.25 and 2.35. 2.35. 2.35%. So these questions here will definitely be asked on the calculator unless they just ask questions specifically about, say, within 1 or 2 or 3 standard deviations. Like, for example, if I were to go ahead and do this, if I went ahead and put in the value that we have here, the 119.104, 119.104, okay, let's actually go ahead and add 10.7 to that. So that would be 129.804. 129.804. Would you guys agree? Okay. So if it were going to do something specific like this, and you could easily create the table, maybe with that in mind, you could say, okay, what percentage of people's speed is between 119.104 and 129.804? Well, it's 34%. Okay. What percentage of people are less than 129.804 kilometers per hour? Well, then what would you do there? There you go. You just add up 34, 34, 16, 13.5, and then 2.35. Okay. So you remember us doing those by hand as well as on the calculator? Okay. Odds are you'll probably have to go ahead and use the keystrokes if one of these does appear, but there's nothing saying that they couldn't also just do one by hand like this if they gave you the exact standard deviation in increments. Okay. All right. Question. Had anybody worked that one and gotten it correct? Okay. We're saving it for me. Okay. All right. Well, let's look at another one. Number 2. Okay, it's another probability problem, but we're going to be using normal distribution to help us out here. It says a factory uses 2 machines to can fruits. Machine A puts fruit into the cans, and machine B adds some syrup. The amount of syrup is independent of the amount of fruit in the can, and that is crucial, especially when it comes to probability. So that's coming up in one of the last questions, but we'll come back to that. Assume that the masses of fruit and syrup are normally distributed. Okay, exactly what we were just talking about a moment ago. It says machine A is set so that the mean mass of the fruit put into each can is 305 grams, with a standard deviation of 2 grams. So like we were saying a moment ago, this is more likely what you're going to see. They'll just go ahead and give you, here's the mean, here's the standard deviation, here's what we want you to do with that. Calculate the probability that a can contains less than 300 grams of fruit. Okay, so I'm going to write this as the notation that we have been. Okay, the probability of X being less than 300. Okay. Would you guys like to try this one on your own, or do you want to continue to kind of work through it together? Try it on your own? Okay. So I'm thinking maybe 30, 40 seconds. Yes? Oh, you're thinking if you have the percent, if you're taking the inverse. Yes, that's something different, but that's good that you remembered that. Here we don't have to do that. So now that we're looking for less than 300, that means 300 is your upper. Okay. All right. So I'll give you a few more seconds. That's absolutely right. What Spencer was just talking about was if you were already given the percentage, okay, and you were working backwards to find like an item in your data, like maybe the probability of X, I'm trying to think of something we could do here, being like less than K is equal to, you know, some percent, well, let's just say 20%, okay. Now, remember, your calculator can only handle a less than calculation when it comes to the inverse function. So this one would be perfectly fine, but if I changed it to a greater than, there's something we have to do. Yeah, you're basically on the right track. You'd have to change it to a less than, but then take your percent and subtract it from 100%, or 1, basically. Okay. Good, good, good. I'm glad you brought that up. Okay, so let me see if I can catch up with you folks here. So keystrokes, I'm gonna go ahead and get rid of that, document B. So I go to menu, it was statistics, what? Distributions, normal CDF. Now this time 300 was the upper bound because we want to be less than 300, so I'm going to leave that lower bound as is. If it's a problem where it says, you know, X is between two values, then you're actually provided both a lower and an upper, and you just put both of those in. Okay. Let's see. Forget, what was the mean?
305.
Okay, 305, and the standard deviation was 2. Okay, so 305, the standard deviation is 2. Okay. So I'm getting about 0.621%. Okay. And there we go. So 0.621%. Okay. Machine B is set so that the mean mass of syrup put into each can is 154 grams with a standard deviation of 1.5. Calculate the probability that a can contains less than 150 grams of syrup. So the probability of an item containing less than 150. Okay. All right. So again, 150 has got to be my upper. We've got 154 and 1.5. So let's see here. That's not what I mean. Okay. Statistics, distributions, normal CDF. And I just completely forgot all those numbers. Help me out. We want to be less than, what was 154? Was that the mean? Okay. So I remember 154. And I think it was 1.5? Okay, was that, and we wanted it to be less than 150. Okay, and there we go. All right, so I'd say 0.383%. Okay. 0.383%. Okay. Then it goes on to part C. The factory processes 10,000 cans each day. How many cans each day are expected to contain less than 300 grams of fruit? How many cans each day are expected to contain less than 150 grams of syrup? Then 3, calculate the probability that a can will contain less than 300 grams of fruit and less than 150 grams of syrup. Here's what I want you to do. Work C1 and C2, or CI and CII, whatever you want to call it. Okay, don't do 3 yet, because 3 relates back to the fact that they said the amount of syrup is independent of the amount of fruit in the can. Okay. Now, if you remember what that means, by all means, go ahead and continue. But let's see if you can figure out the first 2 parts of C. Okay. And you'll notice down here, I went ahead and marked out that last little part because it also brings up what? Z values. Okay, so we are not dealing with Z values. You will not be asked to find those. Okay. In fact, one thing that I'm thinking of, it's not this next year, but it's the school year after. They're changing the curriculum in IB, and I'm really wondering if Z tables are going to come back, because at one point they were. We used to teach that, but then they removed it. You never know. Okay, so how would I solve the first and second parts of C? What do I do?
Just apply the 3 percentages to the amount that
Yeah, so see, what we found before was the probability that a can, for example, contains less than 300 grams of fruit. So it says how many cans each day are expected to contain less than 300 grams of fruit. So we've got the percentage, but what am I going to multiply that by? There are 10,000 cans per day. So what I'm going to go ahead and do is just say 10,000. Okay, I'm going to multiply it by, now you got to move the decimal back over, so I'm just going to use the value that was already in my calculator. Okay. So about how many cans would you say? I would say 62, according to the information we have. About 62 cans. Okay, how many people got that right? Oh, okay. All right, anything I can do to help? Okay. Hey, Samir.
So what if you multiply the 10,000 by like the actual percentage that we found?
Oh, now remember, if you're going to perform an operation with the percent, you got to move the decimal back over 2 places. The only time we didn't do that was when we were dealing with compound interest, because it was built into the formula. You divided by 100, which took care of that for us. But every time you got to do an operation with a percent, you got to move that decimal over. Okay. All right, so what do I do to find the number of cans that are expected to contain less than 150 grams of syrup? There you go. We know we found the percent. And see, the one thing I hope that you're really noticing about these problems is that they are using past answers later in the problem. They do have you find, certain things for a reason. So I'm going to say 10,000. Okay. Times, let me go ahead and bring up this one now. All right. So how many cans would you say? I'd say 38. Okay, good. About 38 cans. Okay. Now, C3. Calculate the probability that a can will contain less than 300 grams of fruit and less than 150 grams of syrup. Okay. So there was a lot of rules that came about when we were talking probability before Christmas. And one of them, if 2 events are independent, you can say this. Okay. The probability of 2 events, let's just call them A and B, the intersection of the 2 is equal to, does anybody remember? That is exactly right. The probability of A, okay, there, just said it and I couldn't write it, times the probability of B. But you can only use that rule if you know for sure they are independent. And the problem specifically stated that. Okay, so what does this mean I need to do here? Why did I circle this word and? Because it's the intersection. See, previously we found the percent, okay, of cans that are going to have less than 300 grams of fruit, and we found the percentage of cans that are going to have less than 150 grams of syrup. Okay, so what am I going to do with those? we're going to multiply those together. That will be the resulting percentage of those that should fit those two conditions. Is everybody with me? Okay. So again, I'm just going to use the calculator here. I'm going to go all the way back up to the top. Okay. And let me do that. Oh, went too far. Okay. So there's the first one, less than the 300 fruit, whatever it is, times. Okay. Here's the 150 grams of syrup, I think that was. So I'm going to go ahead and multiply those together. Okay. So here's what I'm getting. 0.000024. Okay. Now, of course, remember this is a percentage, so let me go ahead and take a look at this real fast. Let me look at all the decimals. Okay. So it's what's this e to the negative 5 mean? Remember, that's just scientific notation. That's 10 to the negative 5. So I'm going to go ahead and move it over. So I would say 0.002, probably 38. Okay. So let's see here. Where is this? So about 0.00238. Again, I just wrote it out in 3 sig figs. Okay. So that I have an answer on my paper, but I'm going to actually use that full value when I perform my operation. Percent. Okay.
If it's asking you how many cans and not the percent.
Oh, did I put that in the wrong place? Oh, yes. There we go. And then what's that?
No, I would just say that it's your decimal.
And there you go. That's it. So now you're going to use the 10,000 cans a day. So how many cans per day are going to fall into this category? Less than 300 grams of fruit and less than 150 grams of syrup. So I'm going to take the 10,000 and multiply by what? Yep, that percent I just found. So let me go ahead and get past that. So I'm just going to go ahead and take that one and say times 10,000. So it says 0.237. So what would you say here? Okay. Hello? Hey. John. Okay. Because the decimal is so low, I would probably go ahead and say 0. According to the percentage, I would say 0 cans should be produced with less than 300 grams of fruit and less than 150 grams of syrup. Okay. I mean, you might be able to make an argument for either or. The fact that you have at least a portion, you could go ahead and say, well, at least a portion. We could go ahead and say at least 1. But with it being so low, I would probably say 0 cans. Okay, what are your thoughts on that? Okay, good, good. Okay, excellent. So I'd say 0 cans. There you go. See, we had a can-do attitude. We got that problem done. Cans. You know, it's going to hit you. There's going to be a realization very soon. You've got less than 3.5 weeks, and then no more West. Yes. I'm not dying. Well, hopefully. But just saying, no more jokes. People are going to have to go online to the website. I remember when he said that. That was so funny. Okay, questions. How we doing? All right. Eli, we feeling better about review 4?
Yes.
Okay. All right. And then this last one here, just get back to basics pretty much, just a good old algebra problem. It says over a short period of time, the speed of a plane s meters per second can be represented by the equation s equals at squared plus bt, where t is the time in seconds and a and b are constants. When t equals 2, the speed is 10 meters per second. When t equals 4, the speed is 100 meters per second. Find 2 equations relating a and b.
Would it be 10 equals A4 plus B2?
10 equals, okay, he's absolutely right. So I'm just taking these values. Here's the speed s, here's the time t. I'm just plugging them in. So I'm going to go ahead and say, I'm going to switch them around though. I'm going to go ahead and say 4a plus 2b. Okay. Remember, not that order matters, it's commutative, the multiplication. But the 2 squared gave me the 4, and then just 2 times b, 2b. Okay. So now t equals 4 when the speed is 100, or the speed is 100 when t equals 4. What would that one be?
100
There you go. Okay. And then it's just a matter of solving the system, figuring out what A and B represent. Okay. Now I know it's been a while since we've done it. I'm definitely going to go ahead and show you the keystrokes when it comes to the problem, but why don't we do this the old-fashioned way? Choose a method. What were some of the methods we talked about in here to solve the system? Elimination, substitution, matrices. We went ahead and wrote the matrix equation and used inverse. Elimination. Elimination is going to work out really nice. What do you want to eliminate, A or B? Okay, so let's say here, what I would do is multiply through by -2. What I like to do is add the 2 equations so that the opposites cancel, but there's nothing saying that you couldn't subtract the equations. That's also going to give you the same thing. Yeah, okay. So let's see here. That would be -20 is equal to -8a minus 4b. The second equation we didn't touch. 100 is equal to 16a plus 4b. Now we add them up. B's are out. So it looks like what equals what? 80 equals what? Oh, okay, so you went straight to the end. Okay, so 80 equals 8a, so a is 10. There we go. Okay. And then it said solve the equations to find the value of a, but let's say you were going to go ahead and find b, what would you do? Yeah, I just plug it right back into one of the equations. So 10 is equal to 4a, 4 times 10 plus 2b. Okay, so 10 is equal to 40 plus 2b. So 2b is equal to -30. So b equals -15. Okay. There you go. Again, on the real test, you know, if it gives you something like this and says find A, I know you're probably going to be tempted to go ahead and find B because it's math and you're going to want to do it. But I would probably kind of advise against it. I just did it here for the practice and it's math. But you know, you're only going to have 90 minutes, so you want to be very mindful of that. Okay. All right. So I was pretty confident we were going to get review 4 done today, and we did. Any questions? Hey, Luis. Oh, yes, let me show you how to do that in the calculator. Yes, I'm sorry. So let's see here. I want to plug those in. The only thing we're going to have to do is just rewrite A and B as what? X and Y. Okay. Okay, so I'm going to go over here. I'm going to go to menu. Now, where will I go to do this? Okay, algebra. In fact, this right here can be very useful to you. Numerical solve, if you're just trying to solve an equation for a variable, that's very useful. Solve system is what we want. If you're just trying to maybe factor or find the roots of a quadratic, remember the polynomial tools right there? That is really, really useful. Okay, but we want solve a system. 2 equations in X and Y. Okay, so let's see. It was 10 equals, what was it, 4X plus 2B? Or 2Y? Okay, there you go. Yeah. Didn't push equals. There we go. And remember, equals is right over here below your blue control button. And it's missing a 2. There we go. And then I believe the other one was 100 equals 16X plus, what was it, 4y? Okay, and there we go. And that's the nice thing, slope-intercept form, standard form. Just go ahead and plug in the system exactly as you see it. And as soon as I push enter, see there's the 10 and -15. Okay. Remember, what's going to be most useful to you is that calculator. You can use the calculator on both tests. Okay, so definitely know we want to know those keystrokes. Okay. All right. Well, that takes care of review 4. Onward and upward. Okay. So review 5. How many people have had the opportunity to look at this? Oh, yes, Zoe. Oh, yes. Is there anybody else who doesn't have a copy of Review 5? Okay. Yeah. You don't have it either? Okay. Uh-huh. There you go. All right. There you go, ma'am. Thought I saw a hand over here. Hillary. There we go. Okay.
I'd go ahead and get one as well.
Yeah.
That's fine.
Anybody else need one? Okay. Well, how many people have not yet had the opportunity to start looking at Review 5? Okay, so several people. Do you just want to go ahead and call it a day and we pick up tomorrow, or do you just want to keep going? I mean, I'll go ahead and do whatever you guys want. Keep going? Sounds like a plan. Okay. It does not. The answer's insight. Yes. Oh, you need one? Okay. All right. Okay, so let's see here. Number 1, the first 3 terms of a geometric sequence, 24, 36, 54, says find the common ratio. Okay, now what variable did we use for the common ratio? Remember, that was R. Okay. How do I find that? Yeah, there you go. If multiplication is what's going to generate your sequence, then division is what's going to help you find it. I should be able to take just a pair of consecutive numbers, the terms, and then just divide them. So let's see, R should equal 36/24, which would be what? What divides both 36 and 24? Okay, a little bigger. Oh, it will be 1.5. Okay, so 3 halves. I was asking about the factor, but that's okay. 12 being the largest factor. Okay. And then you can also do that. 54/36 will also be 3 halves. Okay, 1.5. Now it says, find the sum of the first 20 terms, giving your answer correct to 4 significant figures. Okay. Now, there were 2 formulas that we had. Actually, I was kind of thinking about that the other day. When we did the lesson, there are 2 formulas that we went ahead and talked about in class, and it was based on the size of R. Like if R was larger than 1, if R was less than 1. Do you guys remember that? Okay. But I'm actually thinking the only difference between them is just putting a negative through it. Okay. Those 2 formulas are actually equivalent to each other. So if you want to go ahead and find the sum of a geometric sequence, I would just go ahead and use this formula right here. It'll work every single time. The sum of a certain number of terms equals a sub 1 times 1 minus r to the n divided by, bless you, 1 minus r. Okay. That formula will work every single time, regardless of what r is. Excuse me. Oh, finally. It is in the chart. Sorry. Hello. Sorry about that. My car's in the shop, so I actually had to take that. Well, see, they don't know. And I finally, I got an email about, hey, would you like to fill out a customer survey about your experience? In the last 3 weeks, I've had to take it to Firestone 4 times. And in fact, the last time I had to take it in, I took it in on Monday of this week, and I had to take it back yesterday. I don't know if some of you may have seen me when I went out yesterday to start my car. It wouldn't start again. So every time I bring it up there, the very first time, they said, we can't find anything wrong. Maybe it was just a fluke. So I'm like, okay. Happens again. So bring it in again, get it towed, because it's always never at the house when it happens. Then they bring it in, they're like, well, the battery was showing kind of low, so it's got to be the battery. Okay, replace the battery. Still doing it. So got stuck at, again, not at home over the weekend. Brought it in. Okay, they said, okay, it's got to be the starter. So I said, okay. So we replaced the starter, and I'm continually paying for these changes that are being done, all the work and labor. And then yesterday, doesn't start again. So the guy just called me because I filled out, a customer survey, and I don't think I was a jerk about it, but I was filling out, I was like, I keep bringing it in, and basically all I get are shrugged shoulders saying, I don't know. I mean, I can understand, things happen, but it's starting to get a little frustrating here. So the guy was like, well, I was just making sure, I thought you understood that when we brought it in, it always started up for us. And I'm like, well, I hope you understand that there's a reason I keep bringing it back. It's because there's something wrong. Okay. What I know about vehicles could go ahead and fit on the tip of this pin right here, because that's not my expertise. Okay. But anyways. But he called and he starts off by saying, okay, there's good news. I'm like, oh, you figured out what the problem is. No, but we finally tried to start the car and it wouldn't start. I was like, and I'm thinking to myself, I'm not bringing this to you because I love seeing your faces. Okay. Anyways.
If they don't fix it this time, you should take it to M&M service on 1414.
I know. It's a very
M&M service?
Yes, very good. It's on 19th Street.
Okay.
No, it's on 14. It's on Avenue L. 1414 Avenue L.
I get there if I go in front. I have my driver's
Okay.
license.
So M&M.
Yes.
Okay. Do you know the owner personally, or?
He's my dad. Yes.
Oh, okay. So that would be a yes. Okay. Well, it's just funny to me because the first 2 times, they said, well, every time we try to start it, it starts right up. And I'm like, okay, but there's got to be something wrong. Well, it starts up for us, so we have other cars to look at. I'm like, oh my God, are you kidding me? Okay. But okay, it's okay. It's not that I'm bad-mouthing Firestone. I'm just frustrated at this point. That's okay. That's okay. All right, I'll tell you what. Unfortunately, that kind of took the rest of our time. But try this one. Use this formula with what we have. See if you can get the answer, and then tomorrow we'll come in and we'll go ahead and start with it. Okay.